Today we're going to talk about web services again. Last time we talked about JSON, the JavaScript object notation, and so this is the main way that we communicate with our servers. So if you have data on a server or you want to access some service, we're going to show you the Bitstamp website API, and they have prices for Bitstamp or Bitcoin. And it's just a publicly accessible API that you can get the latest prices on. And then if you create an account, I do believe you can use that API to buy and sell Bitcoin from that service. So if you guys, have an idea for, a Bitcoin exchange app, and maybe it automatically purchases Bitcoin when the prices are at a certain point, and when it goes up, you sell it, that sort of thing. You can do that all from an app. Be it a web app, be it a mobile app, be it a web application, be it anything that can consume APIs. It's usually used with JSON, though a lot of web services also contain or distribute XML as well. Again, XML on mobile is kind of hard to parse. It's a lot bigger of a format. There's a lot more extras. It's a very rich language, but we don't really need that richness in mobile. All right, so let's do a little bit of review for JSON. Again, this is what it is, and again, it just evaluates to JavaScript. So if you're running a web app using the same API, it just works coming back. And on mobile, we have to parse it, but luckily we have native parsers. So this is easily parsed by Android and iOS natively using some classes. Here's an example of what JSON looks like, and these are just a bunch of nested elements within here. So we use the curly brace notation to denote a JSON object, and what I don't show here is an array of objects, and that would use the square brackets. And in the square brackets, you'd have just a comma delimited list of objects. So here's some code that I'm going to skip over because we don't necessarily do it that way. But I wanted to have it in there for completeness. If you do want to dive into it just to get a rich, this code, if you want to dive in here and just get a rich understanding of how to actually create a writer and do all this fun stuff. But for the most part, we're just going to consume this from the API that gets returned to us from a string. And so in this string, well, I guess I jumped ahead of myself. This is to create a JSON object, so you just create an instance of the JSON object class. If you have an array, if your root element of your JSON is an array, there's a JSON array object, and that works a little bit differently than an array or an array list. But this is how to create it, so we just use a key value pair to put these values into our JSON object. And if you have nested objects, you create those JSON objects separately, and then you can add that JSON object. In this case, we're just calling it JSON, so the underscore JSON here. You can nest that within another JSON object. And so this is how you build your JSON objects, nested JSON objects, etc. This is example from the book. So this is a method called crime. And we're creating a universally unique identifier, so UUID, and we're putting that in the JSON string. We're assigning that to the member variable MID, and then likewise we get the title, assigning that to the M title via a key just called JSON title, whatever that is, whatever that value is in your JSON. I'll show you an example here in a few moments, but this is how we get a string, we get a Boolean, and then we create a date as well from that. This is another way to parse it. It's a lot more involved. They have a JSON tokenizer, but you don't really need to do that. Okay, so any questions on JSON? I'll show you more in depth and other examples of it in the future. All right, so we're going to talk about REST. We didn't get to this last class, but REST stands for Representational State Transfer, and that's just a fancy way of saying HTTP requests, essentially. And so our request methods are put, post, get, and then some not so well used, but, well, it's still used, delete, patch, head, and options. And so you probably won't see those bottom ones that much. You might see delete more often. but our main ones are put, post, and get that we'll talk about today. And so if you ever see the word rest with the E lowercase, that's wise because it's part of the first word. But you might see it all in caps. It's a matter of preference, but just the more you know. All right, so our first method that we're going to talk about is our get request. This is getting a resource from a URI. So a URI is very much similar to a URL, but it's a resource. It doesn't have to be like a website. It could be a file. It could be an image. It can be that sort of thing. So that's why we differentiate between URL and URI. And a get request is what most web browsers use to get a web page. So most web page requests are get. So when you type in google.com, that sends a get, and then for the host name, http://google.com / whatever the rest of your URL is. So that's getting whatever HTML is, and the response to that get request is a string of HTML. And what your browser does is it parses that HTML and then displays a web browser, obviously. So we're going to use the same type of request, but instead of getting HTML back, we're going to get back a JSON object. So that's how that gets. So it's pretty self-explanatory. Now the ones that are a little bit not so much self-explanatory is a put. These have many different definitions, but this is a standard, so there's actually only one definition of it, but people use it kind of, REST is more of a methodology, it's not an implementation, and so a lot of people implement these differently. But anyway, a put, it puts or replaces a new resource, actually I should say resource, onto the server at a specific or a specified location. So this is often for updating a record, but not always. And so for example, if you want to change your username, you can update your username. That would be a put, and that is specifically putting that data, let's just say, on top of your current username. And so it's specifically saying, put this data exactly here. I don't think this example that I have in here is exactly the good one. Let me update this for the notes, but okay. So what I did here is I added a user ID to the end of this to specifically make this a part of my URI. And so this API is not just user, but it's a specific user, namely user ID 123. So no big deal. But we're saying name equals, here's the new name types of stuff. So again, this is updating information at a specific point in my API, as opposed to a post, which just takes data and says, I don't really know where to put this, you handle it, okay, that kind of thing. So this sends information to the server at no particular URI. So the example I have is just API/user, and then I'm going to pass all of the user information. And so this would be for maybe creating a new user, but not always. Maybe you can do a post to, let's say, API/user/image, and that'll upload an image to that user's account, but not at a specific location, right? And so what a lot of people do is they equate puts to updating information and a post to creating information or a record or something like that. That's not strictly true, but that's how a lot of people define that. It doesn't say anything in the standard about that a put is an update and a post is a create. But again, that's how a lot of people think about it. All right, a delete is just what you think it is. It's removing that resource. So if you're removing a user, usually define these methods as deletes when you're creating your API. We're obviously not going to be creating any APIs in this class, though if your app talks to a backend service that you might want to implement these types of APIs. And so what's the methodology that you use? It's either a post, put, delete, or get. And so here's a website that you can test all of this grand stuff. Actually, I had this open already. All right, so you can go to this website. It's just called jsontest.com. Let me expand these a little bit for you. Oh, and it's responsive. That's very nice. All right, so they have all these services in this website that you can just hit and, you know, test out if you want. So if you're going through some exercises in Android and you want to just see if you can hit these with your Android app, that sort of thing, you can do this as well on this website. So the first one under services is an IP address. And so what this will do is you hit ip.jsontest.com. You can do this with your web browser because all web browsers use the GET request. And so if I hit this, I'm going to just right click and open up in a new window. Oops, the application is temporary over its service. Okay, well hopefully this, there's always something that doesn't work, right? Huh. Okay, so apparently we can't use this service at the moment because whatever service they're using is, they've reached their limit of whatever it is they've reached. So apparently their server's down. But what this would normally do is you would call a GET against ip.jsontest.com, and what it would return to you is JSON. And so the return on this case, just as an example, is a JSON object with key IP and as a value 8.8.8.8.8. And if I was really to go to this service, it would return my actual IP. So this is pretty useful. But this is all logic that's handled on the server. The server does some calculations and then it returns whatever data it needs to. And so there's other things in here, like you can get the current time and date by hitting date.jsontest.com, and it'll return this JSON object. So this JSON object has three values in it. The first one, key time with value 035325 AM, so that's obviously the time. Then the other key is milliseconds since the epoch, and that's just a number. I think it's what's the date on that? 1970. It's like April 1st, 1970, or some weird number like that. That's how many milliseconds since that date. Don't quote me on that exact date, but that's what that means. And then finally, the date in month, day, year format. So date is the key, and the value is this. And so going back to our JSON code here. So if I was to call this and then pass that JSON object into my method here, instead of JSON title as a key, which probably equates to something like title, I would use date or milliseconds since epoch or whatever here. This is my key that I'm passing into my get. Oops, that's not wrong button. So these are the keys here, and what those methods return when I pass in those keys are the values. And so this is how we parse the JSON object. Okay, so I can't really show you this, but let's show you a real API. Again, this is our Bitstamp API. You just go to bitstamp.net, and then there's an API link all the way at the bottom to get to this, or you can just do /API. Let me expand this as well. And so I showed this last class, but I'll only show it again just in case you either forget. Let's see, which one? Okay, yeah. I don't want to highlight the whole thing. Okay, so this one, it's telling you, let me expand that just a little bit more. It's telling you that this request is a GET request. And so then it's telling you the API that you should hit, or this is the full URI of the API. Let me open up a new web browser. And so when I get that request, or I get that API, it tells me, here's a JSON object. You can see it's not nicely formatted because it's trying to save space, so it doesn't have all these extra characters like new line characters, tabs, or spaces, whatever. It's just putting it basically on all one line. So that's what you get back. You pass that into your JSON get. So if I was to get the string hi as a key, it would pass back 377.0. And you probably don't remember what last time we did this, but these numbers are different, so this always updates. If I hit refresh on it, sometimes these numbers change. I guess I have to wait a second, but the volume actually changed a little bit. And so on your application, you might pull this API, every 30 seconds, every 3 minutes, every 10 minutes, or whenever your app launches, that sort of thing, to get the latest number. And we have other ones. So that was just the ticker for these Bitcoins, the price and everything, and they give you what the JSON dictionary, what this gets returned as, so last, high, low, VWAP, and so you can actually see what VWAP means. It's the last 24-hour volume weighted average price, and then volume, bid, and ask. And so it tells you what all those values are, and so this is essentially the documentation for this. Let's see what else we have. Okay, so if you want to do more than just get that information, if you want to post to their server, maybe to buy Bitcoin or sell Bitcoin or change your username or change your account information, you need an API key. And so usually that you get this by signing up and then going into settings or whatever in their application, getting an API key, which is not tied to your username and password. But once you get that, you can post. And so we have post, and you can do post.api.balance. And what this will do is you have to pass in your API key so they know who you are, a signature of this, and then these nounces, which are explained up here, which I won't go into. But you're actually posting data to this particular API, so API/balance, and what that will return is your balance in US dollars, which you then have to convert over to pounds or euro, depending upon what you're interested in, and then with the Bitcoin equivalent of that, or I'm sorry, the Bitcoin balance, because you can have both dollars and Bitcoin, and then you buy and trade both of those, and then a whole bunch of other things in here. And so you can buy and sell Bitcoin using these APIs, and so you just pass in a little bit of information. So that's just getting the balance, but if you wanted to actually make a transaction, you would pass in, just trying to see what this one is, open orders, order status. Okay, so I won't go into too much detail here, but you can kind of see how you can interact with these transactions of buying Bitcoin, selling Bitcoin, seeing your open transactions, because you might say, I want to sell Bitcoin for $1,000 per Bitcoin. Well, if you look at the API, it's only selling for 377, or actually 373. And so if you want to sell it for $1,000, that open order will stay open for forever. If you guys know how open markets work, you can sell your Bitcoin for whatever you want. However, people won't necessarily buy it for that price. Okay, so let's go back to... Okay, so how do we actually consume these APIs in Android? I showed you an application called Postman, which maybe I'll show you in a second here, but how do we consume that in Android? One way, and this is the most basic way, and this is the built-in Android way, is to use what's called an async task. And so this is how we do very, very short background tasks in Android. And so I've linked to the documentation if you want to find out more information on it. We won't go into it this class because I'll show you a different method, but let's talk about async task really quickly. What you do for async task is you actually subclass an async task. And so I'm calling my example class that I'm subtasking or subclassing called get resource task. And so this is going to be my class that I use in order to consume my API. So it extends async task, and it's a template, so it accepts a string, an integer, and a Boolean, which we'll get into in a second. But these are, the string is actually what your async task is going to return. The integer, I believe, is the progress, so if I think it's between 1 and 100 or something like that, and then the Boolean is the result. And so actually, here's the example. I didn't know if I had this in here. Parameters. So this is the type. Well, actually, let me show you the example first. Okay, so the first, let me back up. This is just an example, but in this example, I'm passing in a string for the params, the integer for the progress, and a boolean for the status or the result. And so what this is, okay, remember the first one is strings. So in parameters, the type of parameter sent to the task upon execution. So I'm actually going to pass in a string, namely the URI to the API that I want to execute. So you can, if you want to pass in an object, you can do that as well. But in this case, I'm just passing in a URI. The progress, so the progress is in units, and it's just as it goes in the background, you get these numbers back. So if you want to have a loading bar to say how much progress has passed, or if it's 50% loaded, that sort of thing. Usually with APIs, there's not a whole lot of data, so you get it back almost instantaneously. So I don't really use that too much. But then finally we have results, and that's the type of result that we get back. So that's a boolean: true, did it execute properly, or false. Now, if you're dealing with URIs, you might want to put in maybe an integer or a string to get back the result, but it depends on what you're doing with that result. So for an API, if you want back JSON, you might make that a string rather than a boolean. We'll go into more examples here in a second. But we have these other. So when you when you subclass your async task, you have these overridden methods that you can override. And the main ones here are do in background. So this is going to be the method that actually gets spun off into another thread, and it does all of your work for you. So do in background would be where you're making that HTTP request to get that data or post that data or put that data, etc. And then finally, when that task is done, let's pretend it's a really long for loop or it's a really long request. Whenever that's done, do in background returns, and on post execute gets executed. And on post execute, however, that actually gets run on the UI thread. So let's talk about threading for a little bit. Most of you have probably taken operating systems where you do threading. Is that right?
Yeah, they do it at 200
Okay, perfect. I don't think I did until my 300 level class, but anyway, when you do threading, especially in Android, you don't want to update your UI, so your widgets, your buttons, your whatever it is on the UI. You don't want to update those things in a background task, because one, Android will throw an exception, your app will crash, but two, you run into a lot of collisions and race conditions, that sort of thing, when you're trying to maybe have multiple background threads trying to change that element. So you never update the UI thread, or you never update the UI on a background thread. And so what happens is that do in background method is in a different thread. It's executing in the background. Your UI is still responsive. You can still click on buttons, and your click handlers will still execute while this do in background method is running. And so it can take 5 seconds, it can take 10 seconds, it can take 200 milliseconds, whatever it needs to do. But then finally, on post execute, that's where it comes back to the UI thread. All of your information from your background thread is passed to this on post execute method. And so this is a really nice way of doing intra-thread or inter-thread communication. And so communicating between two threads, if you guys have done any hardcore C, low-level threading libraries, that's very difficult to get that right. And so this handles it for you very, very elegantly. And so here's another couple of overrides that you may want to use on pre-execute. And this also is on the UI thread. And then on progress update. On progress update gets called independently of that do in background, and it gets called periodically, or you can call it yourself. And again, this is called on the UI thread. So if you have a loader widget or a progress loader, you can update that, which is a UI element, in this method, because this is on the UI thread. So keep this all in mind when you're trying to run this kind of stuff. Let's see. So this is an example of how to, once I've subclassed this and overridden my methods and put in my logic in my code, this is how you actually create an async task, a subclass, or an instance of that subclass async task. So I'm calling new, and I'm sending get resources. And now if you remember, the parameter that I had was a string, and so all the way in the right hand side here, resource URI string. And so this is the resource URI string that I'm passing in. And what this looks like, it could be anything. It could just be google.com or http://google.com to be verbose about it. And once I have this assigned to my get resource task object, which is of type get resource task, it's just a member. I don't have it declared here because it's a member of my class, of this class, or it's probably an activity that I'm doing this in. I call .execute on it. And when I call .execute, I pass in some parameters. And one thing to be very aware of is once I create an instance of this get resource task, and then I call get execute on it, that instance is done. I can't reuse it. I can't keep calling .execute on it. So for instance, if I wanted to keep requesting that resource, maybe for example that Bitcoin price, I can't use the same object to continuously grab that value and see what it is. I actually have to create a new get resource task. And there's many reasons why, but essentially you don't want to call these things 2 times in a row because you would be doing 2 background tasks. And so it can only be run once. You can reassign it to the same variable, of course, using the new keyword, but just keep that in mind. All right, so in our do background task, how do we actually make the, yeah?
Can you go back to the previous slide?
Yes.
So you're saying the execute method will start the background task, right? And then I can create a new get resource task and start another. They're going to be running probably at the same time.
Yeah, so if you have another new get resource task and you do another execute on that new instance of it, yeah, they'll happen. Yeah, they're race conditions, right? So they're kind of simultaneous. But yeah, you can create all these things and execute them all at the same time, and however many of these tasks you can run at the same time is really up to your Android device. I don't know, you can have hundreds of threads, but probably slow down your system a little bit. So once you execute that task, it's immediately going to go into, well, not immediately, but perceptually immediately, it'll go into your pre-execute. This the guy on the top here, the pre-execute, and then what it'll eventually do is do in background. But you don't know because it's all in different threads. So these things are kind of happening simultaneously, but the on pre-execute is obviously going to happen before the do in background. But in the do in background, we haven't actually gone to the server yet to request. So how do we do that? We use this package called default HTTP client. So this, if you wanted to import it manually, this is where it comes from. So it's an Apache Java package here. I don't really know what to call it, but it's from the Apache.org organization. And so if you put this in here, it should be in your Java packages in there. You can actually use. There is another one called, I think it's also called default HTTP client, but I think it's a Java package. So if you're having troubles with it, make sure you're using the Apache version. I seem to run into that a couple times, but I'll tell you all this stuff, and then I'll tell you not to use it. I'll show you why in a second. But this is the base way of doing all this stuff. So I want you to understand this first, and then I'll show you the really, really easy way of doing all this stuff. So why do I say easy way? Because if you look at all these steps, there's 5 steps to get a URI. So we create a HTTP params object. So we create an instance of that class. Then we do a HTTP connection params constant. We set that to, I'll show you code in here in a second. Number 3, create a default HTTP client. This is going to be our object that actually makes the request after we create all these other objects, package those objects into this client, and then we create an HTTP get request. This is the actual get object, so we package in the URI, that sort of stuff. We package that all into the get, and we throw that get at our HTTP client to actually make that request. It's a bunch of steps here. And then finally, on number 5, we use the HTTP client object to execute the get. So if that's all confusing, you're not alone. But let me show you the code here real quick. So step number 1, HTTP params. We create just a basic HTTP params object. We're not passing anything to it. But this would be, if you wanted to pass in query strings or that sort of thing, you can pass it in here. And then we have a HTTP connection params, and this is different from the previous params object. This is step number 2. And we set a timeout in this case. There's a bunch of other things you can do with this connection parameter object, but one of the most useful one is actually setting the connection timeout. And so we're setting this to 30,000 milliseconds, which is just 30 seconds. And also passing it the HTTP params object in there. So you're taking objects and nesting them in within objects, within objects, within objects. And so then we take that HTTP params object, we wrap it in a new default HTTP client. And don't worry if I'm skipping over this so you don't memorize it. Number 4, we create a new HTTP get object. And so if you want to do a post, there's an HTTP post object. There's a HTTP put object, etc., etc. And so this is essentially telling the request that this is a get object or a get request. And so when we create this get request, we pass in some URL. Again, it could be google.com, it could be that Bitstamp API as a string. Actually, it's a URL object, which contains a string, yada, 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 if you're familiar with URL objects. And then in that HTTP GET, we set a header that we are accepting application/JSON. This is just the MIME type, if you guys know about MIME types. Don't worry about it too much. If you're looking for XML, or if you want XML back, what you do is you put in the accept header here, and the server will look at this header type and say, okay, well, he accepts JSON, he accepts XML, etc., etc. So you can have a bunch of accepts, but right now I'm telling the server, I accept JSON, so I expect JSON back. And if it can't give you JSON back, it usually throws an error. You'll get some kind of HTTP error, and so you can check against that. Maybe it doesn't pass JSON back. Or if you're looking for XML, maybe it doesn't. So other possible classes, as I mentioned, post, put, and delete. And then finally, after you construct all these objects and then nest them with objects, we have a response handler. So we have to handle the response back, and this is just creating a new basic response handler, nothing fancy. And on that client, we call .execute HTTP GET. So we're passing in that, and then we're passing in a response handler as kind of a callback object. And so that response handler has, basically has the errors and that sort of thing in the responses, and what this passes back is what you're actually looking for, is the JSON string. And so we're sticking that into a string called response. So anyway, that's a lot of steps. 1, 2, 3, 4, 5. It's a lot of code. Usually you don't do this by hand. Like, I always just go and copy it from somewhere. Android has a lot of really good API or documentation, and so I think that's initially where I got it, and then I just copy and paste it back and forth. Okay, so I just told you all of that because I want to show you a better way. But before I do that, let's talk a little bit more about how to do some maybe more advanced things. Maybe you want to use like the Facebook API or the Twitter API in your app to post, tweets or post Facebook statuses from your app or something similar to that. What you'll need for that is basic authentication, and so I actually mentioned that in the Bitstamp with getting a API key. And you use that API key to authenticate, and what they do is they pass back a token. This token is just a bunch of, it's a pretty long string of characters, but we use basic auth, and you can set your username and password in the header for each request, and this also must be done over HTTPS to be secure, because otherwise what's the point of putting in your username and password if it's not secure, because anybody can look at that request. And so here's an example of what we would do if you had to pass credentials to a basic auth service. Some use OAuth, and that's a totally different method, but this is basic auth, just so you're familiar with it. So what I'm doing is I'm constructing my credentials from a string, but I'm using the username :password. This is how we do it. And then we have this byte data, and what I'm using here is a check to see if my build version is SDK 8 or above. And if it's above the API, I use base64 encode to string. And then if it's not, basically if it's before that, I use base64 utility, and this is just a weird way of doing this, but what this passes back is a base64 encoded version of my username and password, so it's not in the clear. That's not encrypting it in any way, it's just the way that they pass information. So for example, if you wanted to post an image, you can't just take that binary data and stick it into a post request. You actually have to base64 encode that image first in order to upload it to the server. So this is just one way to do it. And so as I mentioned, you can set the header accept. In this version, because we're using basic auth, we have to set the header authorization. And so authorization is the key, and the value is basic space and then whatever that byte data returned. It's a bunch of characters and strings. Don't worry about it. If you've never seen base64, this is how you do it in Android. And then finally, well, I guess I have an example of what that looks like. So this is what the header actually looks like: authentication, basic, and then I didn't put all the strings, I didn't put all the characters here, but as you can see, it's just a bunch of essentially garbage. But when you base64 decode that, it'll give you that username and password. So that's how that works. Now that's basic auth. This is tokenized authentication. This is probably what you'll use in Facebook, Twitter, and most APIs are now moving toward this tokenized authentication method. So instead of sending your username and password for every transaction, you actually send that once, and they'll send you back an authentication token, and you do that when you first log in. And so usually there's an authentication endpoint, like a REST endpoint, so like /API/auth or something like that. And that's usually where you pass either your API key, that's a very common method, or you pass your username and password. It just depends on the service. For Bitstamp, when you log in, you can get that API from your admin or settings section. And then finally, when you get that API key, or I'm sorry, that token, you get that token back, or you send that token with every request. So for example, I will send my API key up to the server. The server will give me back a new token, and I use that token for every request. The server can then invalidate that token at any time for security reasons or for session expiration. So what happens is, if I'm always passing in my username and password, the server can never really expire that or say, hey, you've logged out, because every time I make a request, I should always get something back. But what happens if another user logs in from another device? You might want to log that other user out. And the way that we do that in token authentication is to expire the token that the older user is using. And so next time that they try to make a request with that old token, it'll say, no, there's a new token over here somewhere, and you have to re-authenticate. So that's one reason. And it's a better way of sending over, instead of sending your username and password back over. Okay, so I mentioned all that HTTP stuff before. Here's better ways of doing this, making those HTTP calls and everything like that. There are several libraries out there that do all of that for you, and I'll show you why it's so much better. Let me go back to the different steps to remind you. Okay, so we're creating this, we're doing that, we're wrapping in this, we're creating another object, and we're taking that object and then passing that into another object. So that's pretty convoluted. Very flexible, though. You can do anything with that. These are not in order. Let me see. Okay, yeah, this one. So this is in the link. This is in the notes. If you click on that link that I just showed you here, this is a HTTP library called Volley, and it's by Google. So Google makes Android, and Google makes this. So you'd think that these work very well together, and they do. Let me see if I can find some examples. So sending a simple request, and what I've linked to is actually the tutorial on how to use this. So hopefully this helps you. It's not like raw documentation. Right, so this is all we have to do. We have a text view up here that we're going to edit eventually. And so because we're using that in an inner class or an inner method in a class, we make it final. We get a reference to it. And so now we have this object for text view. Okay? And so the volley, instead of doing all that code, what we do instead is we create a request queue. and then we create the URL. So as I mentioned, it could just be google.com. And then in that, we take that, we have a request, a string request, excuse me. And in that string request, we pass in some parameters. The first parameter is the REST method. In this case, it's get. Let me make this a little bit bigger. The second parameter is that URL, so google.com in this case. And then we have a new response listener, and then that is an object. That's this entire object here. So it's kind of like a on-click listener. Is we just pass in two parameters. It's the method type and the URL, and then when we get something back, and again, I think Android Studio creates all these for you, but we have an on response, and that's where we're going to take our text view, set the text. We're setting it to the response objects, and actually just the first 500 characters of that response. If you wanted to, you can put in that entire response if you wanted to, or you could parse it out. If it's a JSON object, you could parse that out. But what this is going to do is just show you the raw data in a text view. So you can copy and paste this into your onCreate method in your application, and it'll pass back. Actually, what it'll pass back is, if you do the request, google.com, and then you look at the source. This is the string. All I'm doing is just looking at the source of this web page, but this is what you'll see. So if you wanted to implement your own web browser, that sort of thing, you'd have to parse this XML or HTML and do that sort of thing. And so obviously this is a very long, it's wide too. So they're saying, well, we don't want the full text in here, we just want the first 500 characters. So this is another way of doing maybe web crawling. If you want to crawl a website with your Android app and only take the first 500 characters. So that's volley. I actually have a... so this is if you want to look at how you do your web services, we have a class called web services. Let me see if I can expand this. Oh, I cannot. I didn't think about this, so you can't see that. Let me go ahead and I don't have this library in here. I'll open up Android Studio so you can see this code in here. All right, let me show you the other ones real quick while that's loading up. So we have another one called retrofit. Retrofit is pretty much the same way that volley works, just a little bit different syntax. So maybe you like this syntax better. And so we have this this annotation here. So get user slash, and then what it has here is, sorry, you can't see. I should have expanded all these windows. It has user, but in curly braces. And that's because what this API is going, or what this library is going to do is it's going to replace whatever's in those curly braces with what you put in this path object as a user. So if your username is user123, it'll actually put user in that API, because that's how a lot of APIs work. Is you construct your URI based on the parameters. So instead of putting parameters in as a query string, you put them in as the actual URI here. Here's another one, so you can say let me find you a good example here. Okay, so users list, and then you can also put in these parameters, the query string parameters, as I mentioned. And again, here's another way of doing string replacement on your URIs. So group ID users, and you just pass in the group ID for that. And if you're familiar with the APIs, this is how you get that to work. But yeah, so it's a very, very different syntax from the volley. If you remember, volley looks more like this, probably something you're used to in Android. This is using annotations. So I kind of like the annotations, but it's not that flexible. And then finally we have OK HTTP. And again, that works kind of similar to retrofit. You create a new HTTP client. You have this request builder. You pass in the URL, and then you say build. This is using the build design pattern. So we're doing design patterns for project 1. So if you look up the builder design pattern, this is kind of how this works, and you just string along all your method calls. And so this is just creating a request with the URL, and then we have the client that we created up here. We're doing a new call and then .execute, and then we get back this response. It has a body, so the responses have a body, and then we get the string from that body, and hopefully that's JSON that we can then parse from there. So we can return this as JSON and then parse it as JSON, but this is right now as a string. This is how to do a post, so a little bit different. I talked about the MIME types. I guess they're calling it media type here. And then we're doing the character set. If you guys want to do that, that's fine. That's a little bit verbose, but sometimes it requires different character sets. And then the only thing that we have to change is in our builder, instead of passing in just the URL and say build, we also pass in the post body. So the body is defined up here. We're just passing in the JSON objects that we created. So whatever one you want to use for this class, this will be done in project 2, so getting a little ahead of ourselves, but you can use these libraries. If you find another one, let me know. Say, hey, I found one that's even better than Volley. I prefer Volley. Again, it just looks more like the Android development, the patterns that we're using in Android. Retrofit actually has a different reason why it exists. I think to retrofit applications that use the old HTTP request that I did show you in the notes, but I've never used it. So I found this article because I was like, okay, well, what other, besides Volley, OK, HTTP, and retrofit are there? And I was looking to see if there are any new ones, because there's always new ones. And so I found this article, and they give you a bunch of different user interface libraries, networking libraries, et cetera, and it's just a bunch of third-party Android libraries that you can use in your applications. So the one we have here, Action Bar, Sherlock, Pull to Refresh, Android Pull to Refresh. So if you want to implement Pull to Refresh, that's not a standard Android library. Like, you can't just use that in your code. So somebody's done that for you, where you pull down your list and it refreshes just like Facebook does. There's a pager view indicator. There's a couple other things in here. Apparently there's a chart engine. Here's your networking library. So OK, HTTP, Volley, Android asynchronous HTTP client. I've never used that one. Google JSON, which is very similar to JSON, but it's a little bit, it's geared more toward these requests and everything. It's a little bit better, but it's different. So you want to use that and then retrofit. If you want to do like image downloading and caching, there's Picasso, which I think uses the Picasso web service from Android or from Google. Universal Image Loader, so if you ever want to have somebody do that for you, these are great libraries. I'm not going to go through these all, but there are database helper libraries, or Lite, which we'll probably get into. Active Android, I think I've used before, and then other ones. Android, I don't know if that's annotation. It should be annotation. Event Bus, Auto, and Dragger. So Event Bus and Auto are excellent libraries for notifications, and I use it in my web services code that I'm going to show you here in a second. I chose Event Bus over Auto, which is, let's see here. And what Event Bus does is, when you have multiple objects that care about some kind of event, maybe that HTTP request coming back, maybe multiple objects care about that. Well, instead of passing in references to those objects that care about it, what you can do is you subscribe to that event, and then whenever that event happens, you can post or publish that event, and all those subscribers get notified about it. And so what does this look like? Let me show you in code. What code is this? That's project 1. Let's see. Okay, so I'm just going to stick it in. This is just like a example application. But I have this object called Web Services Controller. And so I'm going to go ahead and create a new Java class called Web Services Controller. Sure. Keep that package name. Package name there. Okay, so volley's not going to be, it's not going to know about volley. I'll show you how to install that in a second here if I can find the, and also I have an event bus. So let me comment these out for the time being. I also have event bus in here. But this is using volley. Let me switch over to presentation mode. Okay, so we have a, these are going to come up in red because I don't have the library imported properly. But we have a request queue, and so again, these are where all the volley requests go, and volley handles, if I throw 100 requests at it, say I get this image, this image, this image, a request queue handles that. You can throttle it, you can prioritize, a whole bunch of really cool things like that. Now, the one method that I have in here is a publicly static method, so I can get this from anywhere in my application, called getLocationData. And what this is going to do is it's going to use the Google services, or the Google Maps API to go and get data based on a latitude and longitude. So what I have here is you pass in an activity context. Usually we pass back activity context just because we have to know which activity is calling this. And then what I'm doing is I'm saying if request queue is equal to null, meaning I haven't ever used it before, create a new request queue and pass in the context. So this is really why I need that context in there. That is not what I want. Okay, so this is initially null. When I first call this, it gets initialized. Now, what I do is I have a location object, and I get that location object from what this location, and you can't see that because it's being, oh well. Okay, because I don't have these libraries in here, it's gonna, yeah, that's not the library I want. So anyway, I have this location controller called locations controller, and I have this method called get current location. I'll show you that in a second. Let's ignore that for right now, but let's just pretend that this location object has a GPS coordinate in it. And so what we do for volley is we have a request, string request, and we're passing in the URI, or the URL, whatever you want to call it. And this is, I'm sorry, you can't see that. This is the API. So it's just maps.googleapis.com/maps, yada, yada, yada. But then as query strings, we have a lat long object, and then I'm just constructing this string using my location object. That's going to annoy me. Get latitude, get longitude, and then censor true. And what that's going to do is it's going to basically, if you type that into a browser with some actual GPS locations, it would give you a bunch of values, and we'll talk about that in a second. As a third parameter, if you saw that comma at the end, I'm passing in a new response object, and so again, this is just following the volley, that code that I was showing you on their documentation. We have an override called onResponse, and then down here we also have a error listener just in case it comes back as an error. And then that's the end of that method, that statement. So there's one huge statement, and everything goes into our request object here. And then to actually execute it, I add it to the queue. And so the queue will handle it for me. If there's already 100 requests in the queue, it probably won't get executed right away. It'll go through that first one. Or you can set priorities on it and make it a first priority, that sort of thing. Even though there's 100 requests in there, if you make this like top priority, it'll get bumped up to the top of the queue. So in our actual onResponse code, it gives us the response. So hopefully this is JSON, because I'm going to parse it as JSON. So I wrap this in a try-catch block, not that important. We create a JSON object. I'll post this code later, so don't worry too much about it. But have this JSON object. I'm creating the JSON object from the string. I'm just passing the string right into this constructor, and it works just that way. And then what I'm going to do is create a JSON array called address components. And I'm going to pull out the address components from that because I think, let me just type this in so you know what this looks like. So latitude, longitude. Okay, so I would have to type in a real sorry, I should have done this before class, but let me just say get GPS coordinates. I want to actually pass in some real values here. Then the second value, so the longitude. Again, you can get this from the Genymotion one here. And then what's it actually looking for? Oh, okay. Sorry, it's over here. Okay. Okay, so all I'm doing is just constructing that. This is what the URI looks like. Hit enter. Here's the JSON response for that. And so you can see there's a results array. So in my code, it keeps bringing me back there. So in my code, I know that first element is an array. So I say get JSON array. The key is results. So that's matched up with that results. And so you can see it's using a square bracket. And then in that, we have many objects in here. The first one is address components. Okay, so I'm just stringing these along. I'm saying get the first JSON object in that array, and then inside of that, get a JSON array called address components. And so again, that matches up with this key. And again, this is an array with a whole bunch of objects in here. This is one object. This is another object. And so each object has a key called long name, short name, and types. And so because I passed in this GPS coordinate, it's actually telling me here's all the locations at that GPS coordinate. So we have New York City Hall, we have Lower Manhattan, we have New York. And so you can go through these. They become less specific. So New York County, New York, which is obviously the state. United States, which is the country, and I have no idea what this 1007 is, but oh, it's the postal code. Okay, sorry. So it even has a type that you can tell what it is, and so this is very useful. So what I'm doing in my code is I'm getting that address component, and then I'm looping through all those those objects in that array. Don't worry too much about the code, but I'm getting each index, so 0, 1, however many long it is. And then I'm saying get the types, yada yada yada. And what I'm really interested in this case is if as I'm looping through these objects, I reach administrative area level _2, which is this one, it's going to get me the county. If I wanted the state, I would get it based on this key. And this is just based on their APIs. This is just how it comes back. And so this code is actually looking for what county you're in. So if you're in Ada County, and you pass in a GPS coordinate, this API will tell you if you're in that county or not, or if you're in Canyon County, or if you're in, whatever counties are in Idaho, Boise County, that sort of thing. So this is a really cool way of figuring out, again, not only what county you're in, but all these other methods. What city you're in. You're in Manhattan, or actually, Manhattan's a municipality, I guess. But yeah, so this is one way to do APIs. Now, once I get that API back, you can see that I'm not actually doing anything very valuable with that on first glance. But what I am doing is I have this location data change event. This is just a class actually. I think the class doesn't even have any code in it. It's a class. It's just declared as location data change event, and yeah, that's it. And now if I wanted to put data in this event, I could do this. But what I'm doing is I'm saying data location change event sent county. So I have this member in there called county, and I'm setting it to this value of string. And then what I'm doing is I'm doing event bus and then getting the default event bus because there's only one event bus, and I'm posting that event. And so what this is going to do is this is going to say, hey, I've downloaded this county. This is the county name, and I'm publishing that out, kind of like a radio station. And anybody that's tuned into that radio station address, like 99.9 or whatever, you can say, you get all that information. And of course, you can be subscribed to multiple events. But anybody that cares that my location or my county is this will get notified somewhere in code. It's detached. It's not, it's. We'll show you this in our implementation of Project 2. But I just wanted to show it to you, show you an example of it, and then hopefully you can understand it better when we get to it. Okay, that was a lot of information. What else did I want to show you? That was the bitstamp thing. I wanted to show you the location controller. Okay, so I kind of skipped over this first line of code, which is actually really, really important. Okay, you can't see it because I think it keeps popping up. This, location. How do I get my location? How do I get the device's GPS location? This is kind of important when you're trying to find out where the user is. So I'm going to create another Java class, and I'm going to call that locations controller. Keep that package name. Okay, and again, I'm using the event bus here, and all my other packages seem to import okay. All right, so for my locations controller, let's actually just start going down here to my start location reporting. So this is where I'm going to call, this is what I'm going to call at the beginning of my application in order to start getting notifications of my GPS coordinates. And again, I pass in my activity context, and so again, that's usually main activity.this or sometimes just this. The keyword this, that is. We're checking to see if the location manager is null, and if it is null, we create a new location manager by calling, this is the Android specific service call on our context. So this is why we have to pass in the context. Context.getSystemService. And there's many services in Android. This one's location services. This is the GPS coordinates. Let's see if this is a fill-in. We have an alarm service, we have an app widget, we have a battery service. So if you want notifications about battery levels, this is how you do this. Bluetooth service, camera service. We talked a little bit about that, but in a different manner. Captioning, fingerprint service. So if you want to actually use the fingerprint on some of the newer Samsungs, I'm not sure what other manufacturer has the fingerprint, the thumbprint thing on one of the buttons there. You can use that. There's a bunch of other ones I won't go through, but you can see how you get access to these hardware services. Actually, not all of them are hardware services, but they usually do tie into the hardware somehow. Okay, so what I'm getting is the location service, and what this is passing back is a location manager that I'm then going to use to pull out my GPS coordinates. And so on that, I have a location listener. I create a new location listener, which is an object, and I'm creating these overrides. So on location change, this is a callback that gets called every time that the user moves. And so, for example, if the user steps outside and starts traveling down the street, this method gets called over and over and over and over again. And it passes in a object called location, or a location object. In this case, I'm calling it location. And what I can do is I can set that to what's called the last good location, which is declared at the top of my code. Because what I want to do is I want to know if my location is better than the last, and that's defined down here. And I got this example code, I think, from Google. But it's a very robust way of figuring out, hey, is this location better than the last location in terms of accuracy, in terms of time, in terms of like all these different things? You can read the parameters, but that's not important as just understanding that is the location that I'm receiving better than the last good known location, and if so, set this current location to the last good known location, and then I'm using the event bus and I'm posting this location event object here. And that location event object essentially just sends it out to anybody that cares in my application, cares about the location change. And then I have a couple other ones like on status change. And you can see I'm using the log.i, which is shorthand for the info. My tag is just my initials, and then I'm posting this out here. So I'm just posting this out to the console and saying, okay, well, the status changed, or the provider was enabled, or it was disabled, that sort of thing. And so if you want to have code in here that says, well, the provider, meaning the location services, has been disabled, then maybe stop trying to report the user's location or pop up a request or something like that saying, hey, you don't have GPS information, or you don't have the GPS location because it's either bad or the user turned it off on their device. There's a bunch of ways that could be disabled. And then what I'm doing on the location manager, request location updates, and I'm just passing in a few constants that I have declared. So the first one is the GPS provider. We'll get to that in a second. The location time refresh rate, the location distance refresh rate, and the location listener that I set up in the lines above. So let's go back up to the top because I skipped over those on purpose. The location time refresh rate. This is telling the GPS manager, the location manager, hey, only refresh every 2 seconds. Don't do it any more than that. And then on top of that, we have a location distance refresh rate. So only refresh it every 2 meters. And so if the user is traveling more than 2 meters per second, it will only update it every 2 seconds as per this parameter here. And so you're kind of telling the location manager update every 2 seconds or update every 2 meters. I'm not sure if it's whichever is larger or whichever is shorter, but this is how you define it. You don't necessarily say, hey, update every 2 seconds. You can give it a refresh rate. And this is to conserve battery power. So if you need meter by meter GPS coordinates, you would set this down to 1. If you just want to know the vicinity that they are in, like maybe it's a general location, like I just want to know that you're in Ada County and let me know when you're in Canyon County, you can set this to 1,000 to let you know that every kilometer I want an update. So that's what those constants are represented, and that's what I'm passing in.
Is that little F there? Float?
Yes, so this is how we do floats in Java. Yep, it's 2.0.f, or yeah, that one. Then we have 2 minutes. I'm not sure if I'm using this anymore, but this is just a constant. I usually don't. This is from the example code. I usually don't name my constants based on what the values are. I usually just give them like generic names, because if I have ever to change this to like 3, the name of my variable becomes pointless. Anyway, so then we have a location accuracy delta. So this is going to this is for that is better. So I just search for that. And so this is in the is better method, and essentially it's just saying, is it better than 100? I think that's that might be meters, that sort of thing. But you can play around with these. I'll post this code up, and then all you have to really do is just call start location reporting. I'll set this up in a proper project, but I just wanted to show you the code, how it works, and this is we'll get into project 2 and how this all ties together. And I think that's all that I wanted to show you for that. So yeah, once that's all set up and running kind of in the background, you can call get current location at any time in any location or any part of your code, and it'll return the class good location. But it's all asynchronous, so we want to make sure that that has time to update. Okay, so anyway, that's all the time we have for today. Again, I showed you how to do web services, pulling from web services, using a particular web service from Google Maps to pass in a GPS location, and get back some JSON, and this is how to actually get the GPS information. So what I'll do for next class is tie this all together, put it into an example application, and then we'll walk through it. And I'll try to post that before class on Thursday, so you can walk through it with me, and then that'll be the basis for Project 2, which I don't know if I posted that yet. I might have, or maybe I'll post it tonight. So take a look at that. Any other questions for this class? All right. See you all on Thursday. Thanks for coming out.